Hi students, let's look at this question here, which is on application of differentiation taken from the year 2014 paper 1, question 11 of the H2 math paper. So a toy manufacturer makes a toy which consists of a hemisphere of radius r joined to a circular cone of base radius r and height h, right? The manufacturer determines that the length of the slant edge of the cone must be 4 cm. So this is fixed. So I think the idea is to understand this is fixed. For any kind of maximization and minimization problem, you have to be able to tell which are the variable and which are fixed. Okay, so there's that. So manufacturer determines that the actual total volume of the toy V should be as large as possible. So basically you want to maximize V, right? So find the volume of V in terms of R. Given that R1 gives a maximum value of V, show that R1 satisfy this equation. Okay, great. I think first stop, identify the two variables. Okay, so it's very clear that the variable here is like H and R and H, right? That's step number one. Step number two, how do you actually relate these two variables together by a given condition? So the condition here is the 4. We could actually use at any given juncture, R and H is related by Pythagoras theorem, right? So you just R squared plus H squared equals to 4 squared. Then that's that. So when you want to maximize the volume of V, you just make V the subject. Okay, I'm gonna write this down. Firstly, I'm gonna write down the two variables. They are related by the slant height, which is 4 squared by Pythagoras theorem. We know that R squared plus H squared equals to 4 squared. Okay. What you want to minimize is the volume. So the volume, what we do is a volume of cone add with the hemisphere below, right? The volume hemisphere. So the volume of cone here, the radius will be R. The height here will be height. Okay. So then you'll be 1/3 pi R square height plus the volume of hemisphere will be half volume of sphere 4/3 pi R cubed. Okay. Now the main thing here is to understand that usually the volume that we want, the variable they want to max or minimize, it comes with two variables. So this is very clear. There are two variables here, right? Okay. So what you need to do is you need to change to one variable. Then it makes life easier. So this case here, you can just make it in terms of H, right? Then we can just expand everything. So I'm gonna make the volume in terms of H. Volume in terms of R, sorry. So H will just be equals to 16. So this is R squared equals to 16 minus H squared, right? So this will be R. 16 minus H squared, R squared. So H squared, R squared. Then this will just change to R squared. Then you just square root it. Okay, that's that. There you go. Done. So I'll change everything to one variable. Then from here, what I'm gonna do is I'm gonna just differentiate this. This we need product rule. All right, product rule here. Then we're just gonna differentiate with respect to R. dv dr will give us. I like to bracket a third out here. Okay, so this is my U. This is my V. Okay, so pi R square half 60 minus R square minus half. Then differentiate inside minus 2R plus 60 minus R square. Then this will be 2 pi R. Okay, now just differentiate this. Then differentiate the one behind, the term behind shouldn't be an issue, right? So I just label this out for you. This is my U dv dx plus V du dr, sorry, dr, not x. From here, what I get is 2 pi R squared. Great, there you go. So done. Once you simplify it, then we are told that when R equals to R1, we know that this is a maximum value. So dv dr is 0. So you let dv dr 0, then I'm going to replace R as R1. So I'll get is 0 equals to 1/3. Then all the R will just change to R1. All right, it looks very ugly here. So I'm going to just multiply throughout everything by 3, maybe 3, 16 minus R1 square. This will be 0 equals to minus pi R1 cubed plus, this is what I get. The reason being is because I want to get rid of the denominator of the R1 square there. So I just expand this in. This will be 6R pi R1 square root 16 minus R1 square, right? Then I'll just expand everything in. Then I'm going to simplify this. So from here, what I'm going to do, I'm just going to divide by pi r1, both sides, right? Just factorize it out. Actually, you can just factorize it out. Okay, because r1 cannot be 0, so I could cancel it, right? So I'll just divide, then I'm getting this as 0. Then I'm just gonna try and square both sides to get my expression there. From here, just square both sides. Shouldn't be an issue. So I factorize wrongly, I removed the pi out, okay? So that the pi here. So just rearrange this. 9, but this will be 45 r1 to the power 4. Then this will be negative 768 r1 square. Then 0 to 4. Okay, there you go. Shown. Great. That's the first part. Okay. Let's look at the part 2. Find the 2 solution. I think for the equation 1, if you can't do 1, you can just do 2 by using your GC. Okay, just check your GC value. Here, what I do is I go to apps, then go to poly simultaneous equation, number 9. Then polynomial root finder, you need a degree of 4. Okay. Then you just press next, then you key in A4 would be 45. The coefficient of x power 4. 0, negative 176, 768, and 1024. I just solve it. Okay, so there you go. These are the values that we have. So you reject these both. Reject as r1 is bigger than 0. So hence r1. They need in three decimal places. So I'm going to write 1.207 and 3.951, 3 dB. Great. So let's look at the subsequent one, which is show that one of the solutions from part 2 does not give a stationary value of v. So I think what you need to do is just put the r into this expression and see which one equals to 0. Okay. So now a lot of students do not know actually you can store value into your r value here. So what we're gonna do is just type this in terms of r, so that I don't need to keep writing this out. So for example, 1/3, right? So 1/3. Then I just bracket this entire thing. This will be minus pi. Okay, then r cube. Just put in r cube here. Okay, then later I'm going to store value in. I'm going to just evaluate the expression here. So once you key in this is my expression here. Just check whether you key in properly. So this is my DVDR. Okay, now I can store the value of r in, which is this guy, right? So what I do is 1.2. So you just put 1.207, then you just store to r. Okay, press enter. This is the value. Then you just copy this expression here, press enter, and press enter again. This will be 18.31, which means this is not a stationary value here. So what we need to do next is then just replace the other value, 3.951, into the calculator. So 3.951, store. Okay, so how do you store it? You just press store, then you just put r value in. Okay, then press enter, then you just copy this guy, enter again. It give you close to 0, but because maybe we use 3 dp is not enough, so maybe we use more than 3 dp, it should give us a 0. So you see that if I were to key in a more refined value here, so like more decimals, then this it goes to times 10 to power. So this could be 3.951. This is close to 0. Okay, so you can just write this basically just means 0.00. So 0.3.718 times 10 to the power minus 4, which is 0. Okay, so you know that this guy is just 0.003718. Okay, so you can just write this is at close to 0. Okay, and hence v is a stationary value. That's it. If you use the exact value, obviously it will be 0. So hence write down the value of r1 and find the corresponding h. I think just use this formula here. Okay, this h is equal to square root 16 minus r squared, right? So that's what we're gonna do. Okay, I use more decimal to find my h. Right. So anyway, that's that. Let's look at the next part, which is sketch a graph showing the volume of the toy as the radius of the hemisphere varies, okay? So what you can do, just sketch this volume here. Then we'll just put in GC. Go to a GC. Then you key this in 1/3. So 1/3. Right. Then you put pi r square, pi r square, pi x square in this case. Then square root 16 minus x square. Then plus 2/3 pi r cube. Okay, so this is the answer. So 2/3. So this is my volume. Then we're going to just zoom. Just go to graph, and we'll see the graph is like that. Right. So you'll see that you can't really see the maximum value here. So what I'll do is you just press trace, then you just put in the maximum value of 3. So let's say 3.951. That's important. You see this is in the hundreds. Okay, so that's why it gives you a sense of you need to adjust your settings here. So you go to the window, you see the Y max is about, the volume is in hundreds, right? 140. So go to window. I'm gonna change Y min to 0 because you don't have 0. You just need a positive value, right? Then Y min here, I will just put 0. So Y max was 139. So I'll put 150 here to see the graph. Okay, so graph looks like that. So this is a graph here. The maximum value is here. Okay, so you don't have like a normal max where it goes all the way up and come down, but it just cuts off here. So you just copy this graph over, should be fine, right? So I'm going to just find the maximum volume by just, you go to graph, right? You just press trace. Then I'm going to put in the value 3.95079. So 3.95797. Just press trace and you get the 139.37. So just copy it down. Okay, so that's how you do this question here. So if you have any questions or comments at all, please do let us know and I'll see you in the next question.